All right, guys, welcome to this page of the notes, and what we'll do is we'll go ahead and do another transformation example problem together. Again, remember, the general form for transformations is y equals a times b raised to the x plus or minus h plus or minus k. Now, a couple of things that I noticed. First of all, I noticed that my b is a fraction. In this case, it's 1/3, which means I have an exponential decay function, but it doesn't change where the a, the h, and the k are. Those are all going to wind up being in the same places they were for exponential growth. It's just I know I have exponential decay since my b is a 1/3. All right, well, let's go ahead and take a look and see what we've got here. I do have a number out in front of my b. So I know that my a is going to be a 2. Now, because it's positive, I'm still going to, my graph is still going to open, well, in this case, open up, but it'll decrease from left to right since my b is 1/3. And since it's a 2, that's going to be a vertical stretch. So my graph is going to have a real steep slope. It's going to kind of take off a lot quicker. My h, since up in the exponent position, my h is going to be a positive 2. I know that's going to shift my graph 2 units in the negative direction since h is the opposite. And k is a minus 3, which tells me that my horizontal asymptote, which would have been the x-axis, will now be shifted down 3 units to y equals negative 3. So let's go ahead and put that in there. Negative 1, negative 2, negative 3. So right through here is going to be my horizontal asymptote. Y equals, y equals negative 3. All right, we're going to go ahead and set up our chart. We'll choose some domain values, plug them in, get back our y values, plot our points, and see what happens. Again, I do know, though, since my a is positive, I will be above my horizontal asymptote. And because b is a fraction, I'm going to be decreasing from left to right. Let's see what this guy looks like. All right, since h has shifted me to the left 2 spots, I'm actually going to start my graph at negative 4. Start my chart at negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. That should be more than enough points, and let's see what happens. Again, don't fat finger something on your calculator. Make sure you do the order of operations correctly. I plug a negative 4 in for x. Negative 4 plus 2 would be a negative 2. 1/3 to the negative 2nd power, right, should be 1/9. You'll multiply that by 2 and then subtract 3. You should get 15. Now, 15 doesn't fit on the coordinate plane I've given you. Okay, no big deal. We'll just throw that one out. Let's go ahead and do negative 3. Negative 3 plus 2 will be a minus 1. 1/3 to the negative 1 is going to be, 1/3 to the negative 1 will be 3. 3 times 2 is 6. 6 minus 3, you guessed it, 3. Let's see, if you plug in a negative 2, you should wind up with a negative 1. Plug in a negative 1, you should wind up with negative 2.33. 0 should get you negative 2.77. 2.92. I apologize, negative 2.92. And negative 2.97. Anyway, really, really close to minus 3, which we knew it should be. My horizontal asymptote is minus 3. Let's go ahead and graph these of the ones I can. Let's see, negative 3, 1, 2, 3, right there. Negative 2, negative 1. Negative 1, negative 2.3. Negative 1, negative 2.3 is going to be somewhere right around there. Somewhere right around there, there. Okay, so looks like what I've got is something that looks like that. Again, I'm sorry, that I really missed that point. Hold up. Let me try again. I really I missed my data point pretty bad, or my coordinate point pretty badly. Let me do it again. Negative 2, negative 1, and then negative 1, negative 3. All right, let's try this again. I'm going to come through here, through. Yeah, there we go. That's a little bit better. All right, there we go. So anyway, make sure you extend your line all the way through the coordinate plane. Again, I'm not going to get super picky about these decimals as long as you're in the vicinity, right? If you've got this 2.77, right, just don't be at like 1.9 or 3.1, right? Be between 2 and 3, -2 and a -3, right? I'll, for the most part, be pretty happy. Just don't cross your horizontal asymptote. You certainly, if you touch it, fine. You're freehanding this, no big deal. Just don't cross it. And it does look about like we thought it was going to. The domain is going to be all real numbers. You can choose any value of x you want to. It'll work. The range in this case, though, is different because my horizontal asymptote has shifted to y equals -3. But because my graph is above the horizontal asymptote, it's going to be y greater than -3. All values of y greater than -3. All right, guys, that takes care of graphing exponential decay functions. It's just like graphing the exponential growth functions. Whether you're doing transformations or just graphing a regular exponential or decay, the only difference is the direction in which the graph increases or decreases. All right, so just watch out for that. Make sure you check out what your base is and kind of get your bearings on the problem before you start doing it. But as long as you use your calculator properly and plot your points correctly, you're going to get the general shape of the graph, even if you forget which one's growth and which one's decay. I got one more word problem for you guys dealing with exponential decay on the next page of the notes, so head on over. I'll meet you guys there.